Okay, today's lesson covers natural logarithms. It's Unit 5, Lesson 6. How we are working through the course this year. It's Section 7.6 out of your textbook. So, it's not really anything new. It's adding to what we have already learned. But just to, again, solidify what we've been learning and hopefully reinforce the concepts to you. The first thing that I want to discuss is if you remember what the natural logarithm, we talked about the natural base. Natural base exponential function meant the base was equal to e. So our natural base function y equals e to the x. And hopefully, if you pause for a second and tell me which one of these graphs it is, you quickly said that it was number 1. That is y equals e to the x. Okay, so the other thing that we have been doing, okay, telling you where this comes from, is if I have y equals e to the x, and I ask you to find the inverse. Okay, I hope you all said to yourself that means that we have to switch the x and the y. So that means x equals e to the y. And then from the last lesson that we just learned, we talked about how to solve. How do we solve exponential equations, which means it's that variable. We're trying to solve for this exponent. Okay, and so what we did is we took the log of both sides. So that means log of x equals log of e to the y. And how do we get the variable or move that out of the exponent so that it's not there, and you all knew that it was to move it in front. So log of x equals y log of e, y log of e. And then y'all tell me that you divide by the log of e, so that gives us log of x over log of e. And then I wrote this down to see how many of y'all could tell me if I could go from here and write that as log base e of x, then you knew, hopefully can see that that's an example of our change of base rule. Okay, so log base e of x, um, that's how I went from here to here, but more importantly, log base e of x, we don't write it like that. We actually write it as ln of x. So y equals ln of x is the inverse of y equals e to the x. The natural base of e, the natural logarithm, written ln. Okay, and just like every other things we've talked about, okay, we have a radical. We don't write a number there, it's a 2. Okay, if you have an exponent and you don't write a number right here, it's 1. So when you see this, you need to know that it's log base e of x. If we write a log without a number there, it's base 10. So different times in math, you got to know what the understood numbers are and what they mean. So this is y equals e to the x. This, of course, is going to be y equals ln of x, or the inverse of our function. All right, so that gives us, now keeping that in mind, if ln is log base e, then what is the ln of e? And the ln of e, okay, if you need help on this first one, that's log base e of e. And we've talked about a lot. This is just a variation of our White House problems. So what is the log base e of e to the first? It's 1. Okay? So pause for a second and try to write this down and then start back up. And you'll be at ln of e to the third is 3. Ln of e to the 51st is 51, and ln of e to the 1/4 is 1/4. And no, your whole test will not be of problems like that, but there will be some on there, so hopefully that will be ones you absolutely get right. Okay, so let's go practice the same thing that we've done before. We're just doing it with, oh, don't start this on me. We're doing it with ln instead of just logs that we've done in the past. This thing's on the other side. Let me see if I can hit this and move it. Nope, that didn't help. Okay, so ln of 7 plus 2 ln of 5. First thing we got to do is get rid of that number and make it the exponent. So that gives us ln of 7 plus ln of 5 squared. How do we bring together addition? Is going to be ln of 7 times 5 squared, and that becomes ln of 175. And I had somebody ask me, yeah, I do need you to write the steps because I need to see the work that supports your answer. So please make sure you do that. Okay, look at the next one. It says 3 ln x minus 2 ln 2x. Okay, so we know that 3 is going to be our exponent. So we have ln of x cubed minus ln of 2x squared. And if you write it like that, y'all, then that says the squared is only on the x. And this whole thing is what I'm taking the log of, so that needs to be in parentheses because we need to know to distribute that. So we now have subtraction, which comes together as division. So on top I have x cubed, and on bottom I'm going to have 2 squared and then x squared. And then we simplify that. I have x cubed on top and x squared on bottom, so I have more on top than the bottom. I have one more, and that 4 stays there. So this is how that simplifies. Okay, last one. Again, y'all are pretty good with the exponents. So this is going to be ln of x cubed plus ln of y squared plus ln of 5. And that is addition, so we bring that together by saying ln of 5x cubed y squared. So again, that should be somewhat review because we did that last week and you had it on your previous test. Okay, now the other thing you did when we talk about solving, you solved logarithmic equations. Okay, and we used this. We had log base b of x equals y. Okay, and we got rid of the exponent. I'm having a little, I'm so, okay, give me a second, guys, because I'm technology. Hold on. All right, let's hope that works. So log base b of x equals y. We get rid of the log and rewrite it in exponential form by saying b, it's like I hit record and it don't want to work on me, b to the y equals x. Okay, now let's use that. Just change it a little bit so you can see it. Okay, if I don't do log base b, but I do ln of x equals y, then how do I write that in exponential form? So you got to think to yourself, if I see ln, what is the base down here? It's e, so that would be e to the y equals x. So that's how we're getting rewriting logarithmic form and exponential form. So to solve this first problem, I have ln of x equals 2. So I'm going to know that there's an e down there, so that means e squared equals x, because I'm starting here, going up, and doing my little circle. Okay, so you need to put that in your calculator. Make sure you know how to do that, and when you do, if you need to pause, I didn't write that correctly. That is going to be 7.39. Okay, let's look at the next one. ln of 3x plus 5 quantity squared. Okay, so that means that I'm going to have, oh, don't do this to me, e to the fourth equals 3x plus 5 quantity squared. Now, how do we solve that? Okay, I hope you said take the square root of both sides. So I'm taking the square root. And we know that the square root of something squared is equal to what we have underneath. So that's going to be 3x plus 5. Yeah, it's not working on me. The square root of e to the fourth is e squared, but you got to remember to do your plus or minus. Okay, so from this point, you know how to isolate the x. We're going to subtract the 5, so I have negative 5 plus or minus e squared equals 3x. And then I'm dividing by 3, so x equals negative 5 plus or minus e squared over 3. Again, please pause and make sure you know how to put this in your calculator. Okay? You can't put a plus or minus in there at the same time, so you're going to put negative 5 plus e squared divided by 3, and then go back and edit that and make it minus. Now, the two numbers that you're going to get, 0.796 and negative 4.13. Now, if you didn't get those, okay, first off, if you have a fraction button that allows you to put it in like a vertical fraction with this horizontal fraction bar, that's best. okay, because you don't have to worry about it. But if you're using a scientific calculator, there's an operation here. So you'd have to put parentheses around this before you hit that divided by sign, or you're not going to get the right answer. So see if that doesn't fix it if you didn't get the right answers. And if you're still not getting them, then you need to come see me. Now, there's another thing that I need to talk to you about, and that is whenever you're solving these things, I hope you remember that the domain of our log function is 0 to infinity. Okay, or that means you can't take the log of a negative number. Can't take log of I should write out the word negative. Okay, of a negative number. So when you get an answer, you got to go back and plug it in and say, if I put 0.796 in here, is that going to be negative? And it's not. If I put negative 4.13, well, that's about negative 12 plus 5. That is negative 7, but I'm squaring it. And when you square a number, it's always positive, so you don't have to worry about it. But if you got a negative answer for something like this, you would ignore that negative answer. So keep that in mind when you're solving these problems. Okay, the next one, this is an example where we have to bring those together. So this is ln of 6x equals 2 because you bring together addition with multiplication. And then your next step is going to be e squared because we're starting down here with e squared equals 6x. And then you divide both sides by 6. So x equals e squared over 6. And put that in your calculator, make sure you know how to use it, and you should get an answer of 1.23. Okay, so on the next page, I wanted to review this again because it's going to come in with what we're doing. So what is 5 ln e? Remember, ln of e is 1, so this is 5. Or ln of e to the third is 3, and 3 over 3 is 1. Ln of e to the negative 7, negative 7. Ln of e squared is 2 over 6 is 1/3. I should have told you to pause first. I hope you did that. Okay, so let's solve our equations. Again, this is what we just talked about. When you have a variable in your exponent, if you can't write them in the same base, we're going to take the log of both sides. Now, what's different about this versus what we did in the last section is your base is e. And if your base is e, it's easiest if you use the natural log instead of log or the common log that we did previously. So this is ln of e, and it'll look like an e, to the x minus 2 equals ln of 12. And I would really caution you not to skip this step because when people do, they forget that little ln right there. Okay, and remember what we've just been doing, ln of e to whatever is equal to whatever. So your exponent is equal to log of 12, excuse me, natural log of 12. So x equals ln of 12 plus 2. Okay, now again, please put it in your calculator. Make sure that you get the answer of 4.48. Okay, if you didn't get 4.48 when you put it in your calculator, you probably forgot to close your parentheses because your calculator generally opens it. You have to close it before you hit plus 2. So again, if that doesn't fix it, please come see me. We want to make sure you get those right. Okay, 2e to the negative x equals 20. You want to isolate that exponential expression first, so we're going to divide by 2. 20 divided by 2 is 10. And now I'm going to say ln of e to the negative x equals ln of 10. So I'm taking the log of both sides. And then ln of e to the negative x, that's our White House problems, okay, where our bases are the same. And so this is going to be negative x equals ln of 10. So x equals the negative ln of 10. And that, of course, is negative 2.3. So if you're feeling good, pause, try to solve this on your own, and then start back up and see if you're getting it right. So here, I need to isolate it, so I'm going to subtract my 5, and I'm going to have e to the 3x equals 10. Again, I'm taking the log of both sides, and you want to write that ln of e to the 3x. It also kind of helps get into your brain that when you see these two together, the answer is your exponents. Like what color is the White House? Answer's right there in front of you. So 3x equals ln of 10. X equals ln of 10 over 3. And that, of course, is 0.77. All right. So our last set of problems is to graphing, just to make sure you don't get thrown off if you have to graph something with a natural base. Okay, what is that natural base again? I hope you told me that or said to yourself that that's E. And remember, that's approximately 2.71828, goes on forever. Okay, um, so as we have talked about previously, the first time when we graph, we always determine what the base is. So the base is 3. And then I talk about that, figure out the asymptote. Is it x equals 0 or y equals 0? And it's this my exponential function because there is no log in it. So it's y equals 0. And our key points, we talked about if we identify that asymptote, then I know that my -1, 0, and 1 key points are going to be on the x side. And then this is going to be e, 1, and 1 over e, just like we've done before. Then we go back and we look at our graph and we say, well, there's a 2 in there that affects the y. There's the 3, then that one affects the y. And if it affects the y, I do the same thing. So I'm going to multiply by 2, and then I'm going to subtract 3. My x's didn't change. -1, 0, 1. And then 2e minus 3. And then 1 times 2, 2 minus 3 is -1. And then 2 over e minus 3. Okay, at this point, you are more than welcome to pull out a calculator and figure out, oh, before I go on, let's talk about asymptote. Did my asymptote change? Yes. 0 times 2 is 0, minus 3 is minus 3. So we'll go plot that asymptote, y equals -3. And now, 0, -1, so I'm going to plot that point. That's always an easy one to start with. Okay, so when you plot this one, round this number, okay? Or you got two choices. You can either round it to 3 just for graphing purposes, or go put it in a calculator if you don't feel comfortable doing that. So just type in your calculator 2e, and remember 2e is the same thing as 2e to the first, okay? So if you have to put something in there. But 2 times 3 is 6, and 6 minus 3 is 3. So at 1, I'm going to go to 3, but I'm actually going to go a little bit less because I know I'm not exactly at 3. And then at -1, I'm going to go, I'm normally at 1 over e, which is about 1/3, and then I'm going to go down 3, which is going to be about right there. So it's a sketch. I'm not going to be too picky about it, but I think you got the idea. Okay, let's look at the next one. Y equals e to the x plus 4. So again, the base is 4. Nope, the base is e. Just make sure you're paying attention. Asymptote is exponential y equals 0. So if it's y equals, then my -1, 0, and 1 are on the x side. E, 1, 1 over e. And I go back and I say, well, this 4 is up there with the x, so it affects the x, and this is outside, so it affects the y. And so with my x, I do the opposite, so I'm going to subtract 4, and with the y, I do the same. So -1 minus 4 is -5. 0 minus 4, and 1 minus 4. Okay, and then I have, what am I doing? I'm adding 1. So this is 1 plus 1 over e, 1 plus 1, and e plus 1. Okay, asymptote, y equals 1, because I do the same thing. So I'm going to go plot my asymptote, y equals 1. And I'm going to graph, I always start with that, -4, 2. And then I have, at -5, it's 1 plus 1 over e. And then at -3, it's about 3 plus 1. So that's going to be 4, but it's a little less than 4. And I'm going to try to connect them before my thing keeps whacking out on me. Meow. So y'all got the idea. Okay, last two problems. doing some logs, okay? But again, every time, if you get in this habit, y'all, of just every time you look at a function, exponential, logarithmic, identify that base. Okay, so base is, of course, still e, but what's different now is my asymptote is x equals 0. Okay, move out of my way. And so if it's x equals 0, then my negative 1 is on the other side. And this is e1, 1 over e. Okay, so I go back and see what's happened. I have a 3, which is outside the parentheses, so it affects the y. Again, 2 is outside. Okay, PEMDAS. If you have more than one operation to the same one, you do it in the same order of operations that we do. Even if there was a negative sign, the negative is like multiplying by negative 1, so it still comes before any addition or subtraction. So I'm going to multiply every y coordinate by 3 and then add 2. So these don't change. And I have 1 times 3 plus 2, 0 times 3 plus 2, and 3 over e plus 2. So I'm going to go graph my oh wait, did my asymptote change, y'all? X equals, my x's didn't change, so it's still x equals 0. So here's my asymptote. And at 1 over e, which is about 1/3, I'm going to graph 1 plus 2, which is 3. So it's about right here. And at 1, I graph, oh, did I do that right? Sorry. Yeah. I thought I was on the different function. Okay, at 1, I'm at 2. 1, 2. And at E, I'm at 5. Oops, hold on 1 second. This is what happens when y'all aren't with me. I used the wrong number. I'm so sorry. I hope y'all weren't cursing at me too bad. I'm not supposed to be using the x. I'm supposed to be using the y. So, negative 1 times 3 is negative 2, and negative 2, excuse me, negative 1 times 3 is negative 3, plus 1 is negative 1. So this point is not supposed to be there. This one, the 1, 2, is good. At 1 over e, I'm at negative 1. And at e, which is just before 3, I'm at 5. So I'm right here. So my graph is going to look like this. Okay, so you can kind of see that 3 stretched out. Okay, last one. B equals 3. Oh, golly, y'all. What am I thinking? Back over here? Woohoo. At least I put it right in my chart. B equals 3. I'm thinking ahead, and I apologize for that. B equals E. B equals E. I think I said E. I just wrote the wrong thing. X equals 0 is what we start with. And negative 1, 0, and 1. E, 1, 1 over E. We got that part right. Okay? So I'm going to go down to my new points. This is inside, so it's going to affect the x. This is outside, so it's affecting the y. I do the opposite to each x, so it's going to be minus 2. I do the same to each y, so that's minus 4. Negative 1 minus 4. 0 minus 4. 1 minus 4. Okay? 1 over e minus 2. 1 minus 2. And then e minus 2. My asymptote is 0 minus 2. So I got x equals negative 2. So I'm here. And again, negative 1, 4. So negative 1, 4. Or, nope, it's not 4. It's negative 4. Negative 1, negative 4. Okay. Then at 1 over e minus 2, which is right before that asymptote, I'm at negative 5. And then at e minus 2, which is about 3 minus 2, which is 1, but a little before it, I'm at negative 3. So we're looking like this. And there's your logarithmic function, natural log function. Okay, apologize for those little mistakes. I hope that that helps, and if you have any questions, please come see me.